With exponentials, it's also very important to be able to identify whether some information or data in a situation is best modeled by using a linear equation or an exponential equation. And identifying these situations and data as having exponential behavior. This can be done in one of two ways. The first way is to look at a table or set of data. So what we're going to do in this short activity is create a table for the function y equals 2x and the function y equals 2 to the x to see the differences between their tables. So what we're going to first do is we want to create a table for y equals 2x using the values -2, -1, 0, 1, and 2 for x. And to do this, what we're going to do is we are actually going to just substitute in these and use some mental math to determine each y value. So if I plug in -2 for x here, it's going to be 2 times -2, or -4. If I plug in -1, it's 2 times -1, giving me -2. And if I plug in 0, it's 2 times 0, or 0. If I plug in 1, it's 2 times 1, or 2. And if I plug in 2, it's going to be 2 times 2, giving me 4. Likewise, we're going to create a table using the same x values for y equals 2 to the x power. So if we do this, first putting -2 into our exponent, we've explored how the negative exponent puts it actually in the denominator, so it's going to be 2 to the second power in the denominator, giving us 1/4. If we put in -1, it moves it to the denominator and actually gives us 2 to the 1 power in the denominator being 2, and for a really overall 1/2. And then if we put in 0 for x, well, anything to the 0 power is always 1. And if we continue, 2 to the 1 power now is 2, 2 to the 2 power being 2 times 2, or 4. And now you can see that there's extreme differences in values here, but it's important to notice what's happening from term to term. And what I mean by that, from one value to the next. And it's important to notice that there is a pattern. Each of the x's increasing by 1 in each of these functions. But we can also see that from 1 to the next, from -4 to -2, there's a pattern that it added 2 to that section. From -2 to 0, it also added 2. From 0 to 2, same pattern is existing, adding 2. And then from 2 to 4 is +2. So from this, we can see in this linear equation, for every value +1 of x, we're going to +2 to the y's. And we can see that this is a standard equation. Now, if we actually look at y equals 2 to the x power, and look at its y values similar, we can explore what's happening from one to the next. So it might be hard to see that from 1/4 to 1/2, if you actually take 1/4 and multiply by 2, you'd get 1/2. Similar, if you take 1/2 and multiply by 2, you would get 1. If you take 1 times 2, you'd get the value of 2. And lastly, from 2 to 4, if you multiply by 2. So when looking at data, it's important to identify it as linear or exponential by looking at this difference between one y value to the next. In a linear function, it will be either an addition or subtraction from one value to the next. For exponentials, what you should find is a pattern of multiplying from one value to the next. Now, as the first way to compare a linear or exponential, or to look for is it a linear or exponential function, is by looking at the data and determining if the y values are being added to, or if the y values are being multiplied from one to the next term. The second way that you can look at whether something is exponential or linear is by looking at the graphs. And if you have a set of data similar to the tables we have, you can graph the two graphs and see whether does it look like it's a linear function or an exponential function. So what we're going to do is we're going to graph these two tables. So y equals 2x Using the table values that we've already used, we're going to graph these points. First one was -2, and when we plugged in -2 for x, we got a value of -4 for the y. When we plugged in -1, we got a value of -2 into y equals 2x. When we plugged in 0, we got 0, so the point 0, 0. Plugging in 1, we got 2, and when we plugged in 2, we got 4. And what you should be able to see is that this creates a nice straight line where we can really see that this is a linear function once graphed. For our other function, we're going to take our points and graph them as well for y equals 2x. When we first put in -2, we got a value of 1/4, so very close to 0. Somewhere around -2 1/4. When we plugged in -1 for y equals 2 to the x, we got 1/2. Plugging in 0 for x, we got 1 for y. Plugging in 1 for x, we got 2 for the y value. And when plugging in 2, we got a value of 4. And you should be able to see that in this case, it doesn't make sense to draw a straight line through all these points. But if you connect these points, it ends up looking more like a curve. And so using these graphs, you can see on the left here, a linear function can be drawn with a straight line, but an exponential function will be a curve. And it's easy then to identify it as being a linear function or an exponential function once they're graphed.